Hello everyone and welcome back to the AI Research Roundup. I'm your host, Alex. Today, we're diving into a paper from the Papers with Code trending list called SLOT, which stands for Sample-Specific Language Model Optimization at Test Time. The core problem it tackles is that even powerful LLMs can sometimes fail on very complex or unusual instructions. SLOT's solution is to make small adjustments to the model right as it's generating a response, a process known as test time optimization. It does this by minimizing something called cross-entropy loss, which is basically a score that measures how wrong the model's initial guess is, helping the model better align with the user's specific instruction. This method shows some really impressive accuracy gains on tough benchmarks. And for those of you who want to try this out, the great news is that the code for this work is fully open sourced on GitHub. The repository really has everything you need to get started, including the evaluation scripts for benchmarks like GSM8K, and even a quick integration guide to help you adapt the SLOT method to your own models. Alright, and this first figure really brings the benefit of SLOT to life. On the left, we see a math problem from the GSM8K benchmark. Without SLOT, the QN 2.57b model outlines a good plan but gets the final answer wrong. With SLOT, it nails both the reasoning and the final calculation. The graph on the right shows this trend clearly. As the number of SLOT optimization iterations increases, both the answer accuracy and the format accuracy go up. This improvement shows how just a few quick adjustments can significantly boost performance. Okay, so we saw the impressive results, and this next diagram shows us how SLOT actually pulls it off. The whole thing works in two stages. First is the prompt stage. The LLM processes the prompt and generates its internal hidden features, which are like a high-level summary of the text. Then, SLOT optimizes a tiny prompt-specific adjustment vector called delta. This delta is added to the hidden features to nudge the model's final output scores, or logits, in the right direction. And in the second part, the generation stage, that same optimized delta is reused for every new word being generated. This keeps the model on track for the whole response, and since the main model stays frozen, it's all very computationally light. So we've seen the mechanism, and this table shows the results in black and white. It evaluates a whole range of models on three really tough benchmarks for reasoning and problem solving: AIM24, Math 500, and GPQA, and the improvements are pretty striking. For example, on the GPQA benchmark, the DeepSeek R1 Distill Llama 70B model gets a solid 3% boost, reaching a new state-of-the-art performance. And on AIME24, some models see a massive 10 or even 13-point jump in accuracy. This data really demonstrates how effective this lightweight optimization is. So those benchmark numbers are great, but this next figure gives us a more intuitive peek into how SLOT is getting those gains. It shows which words the QN 2.57b model was encouraged or discouraged from using on the GSM8K math problems. On the left, the green bars show the words whose logits, which are the raw scores for every possible next word, were increased the most. And it's all words like reasoning, think, and process. Then on the right, it shows the words that were suppressed, things like simple numbers and even the end of text token. This suggests SLOT is nudging the model to produce a more detailed, step-by-step thought process instead of rushing to a final answer. And this next figure gives us some perfect concrete examples of what that improved reasoning looks like in practice. We see three different word problems from the GSM8K benchmark. In every single case, the baseline model on the left makes a simple but critical error. It might misunderstand a relationship between numbers, or it calculates a weekly total but forgets to convert it to a daily one. But the model with SLOT on the right, it lays out each logical step of its reasoning, and that careful, methodical process leads it to the correct final answer every time. Looking at these examples, it's clear that SLOT offers a really clever and efficient way to boost a model's reasoning capabilities. It's not about expensive retraining. It's a simple, targeted nudge at test time that encourages the model to generate a more detailed thought process. This work is a great reminder that sometimes the most effective improvements can also be the most lightweight. Thanks for tuning in to the AI Research Roundup. I'm your host, Alex.